Today we're going to be talking about volumes of prisms, which should be revision. We're also going to be talking about volumes of cylinders, which might be new, and we're going to be doing some volumes of some trickier shapes. We're going to be using a cross-section again, and we're going to be having something that has a uniform cross-section. A uniform cross-section and something with straight sides, well, that's the definition of a prism. Now, it turns out when we wanted to find the volume of something with a uniform cross-section, it's a really nice and easy formula. We're going to use V equals for volume, and we're going to multiply it by that cross-section A. So A represents the cross-section. So let's put an A on this, the area of the uniform cross-section. Now, we're going to multiply it by this length here. And we're going to call this H. And I like to imagine H is like the three-dimensional length. It made this go from a lowly old rectangle, rectangles, into a three-dimensional object going into the page here. Without that H, it wouldn't be 3D. So all we do to find that volume is going to be that cross-sectional area times H. Really nice. So you're going to need to know your area formulae that you talked about in a previous lesson, and you just need to identify what that H is, the length that makes this a three-dimensional object. Okay, let's have a go at actually finding the volume of some shapes. So we want to find the volume of each solid, and we want to give our answers correct to 2 decimal places. Just happens to be 2. We could have said 1 or 15, maybe not 15. So to find the volume, we're going to write V equals AH. Now you might be looking at this shape here, and just a tip when you're drawing this at home, I would draw this funny shape, or one that looks similar to it. Then you draw some lines down, and I like to imagine this line needs to go a bit further down because that squiggly bit sort of came out a bit. Draw another line, and now I'm going to try and draw that same shape that I drew on top. Awesome. So that looks a bit 3D. So, oh my gosh, I do not know how to find this area of this strange shape here, but luckily this cross-sectional area has been given to us. That is our cross-sectional area. So we don't even need a formula to find this area. They've already told it to us. So that means we've done our formula step. Let's substitute. Our area was 22, and we should double check these units before we keep going. This is in centimetres, and that's in centimetres squared. Doesn't matter that 1 centimetre and 1 centimetre squared, so long as they're all centimetres something. Because the 25 centimetres, that's actually the height of this shape here, and that's what makes this a three-dimensional thing. And that area was centimetres squared. That makes sense because it was an area. One thing I don't think I mentioned before, and it's a bit weird looking at it sort of on the side, this height is actually perpendicular to the base or the cross-section of this shape. And that's true for this one here. If I drew sort of a little line here, this would be perpendicular. Perpendicular means at 90 degrees. So this would actually give us 550. Now I want you to think about what units we'd have for this question here. Hopefully you recognize that it would be centimetres cubed because we're dealing with a three-dimensional shape. Okay, with our next shape here, this one actually has a name. This one would be known as a triangular prism. It's a prism because it has that same triangle cross-sectional shape the whole way through. Doesn't matter where we take our slice. If you need help drawing this, I would draw the top one again. I would draw one line going down, another line going down, another line going down, and then that same triangle. What some people like to do instead is they like to draw the 2 triangles and then join up all of the vertices. Vertices means corners, so a corner, fancy name is a vertex, and just like you'd have corners as the plural, you'd have vertices. Fancy. So we actually need to go ahead and find out what the volume of this triangular prism is. So let's put down our formula. Okay, we've put down our formula here, V equals AH. And just in case it's bothering you, there we go. That little green dot's gone from the middle of the screen. Now, we don't actually know the area of this shape. It's not like the last example where we're given the area of the cross-section. But hopefully you notice we've got a little triangle. It might look a bit funny because it's sort of lying down on its side, but that's definitely a triangle. So in our volume formula, rather than writing A now, let's actually write how to find the area of a triangle. You could do that on the side of your page if you wanted, but I like to do it all in one go. So the area of a triangle, that is base times height over 2. Did you know that base times height over 2 could also be written as a half base times height? That's kind of neat to know. Okay, so we've written down that area is base times height. Now we need to multiply it by h. Uh-oh, I've got two h's here. Maybe what I'll do is I'll put a little p on this h here, and that will tell us that we actually mean the height of the prism. The height of the triangle is going to be this h here. I just said ear. And then we're going to have the height of the prism. In our substitution step, what do you think the base of the triangle is? Well, hopefully you recognize with our little triangle down here, this is going to be its base. So that's going to be 12. And the height of our triangle is going to be 6 on 2. So that was our two-dimensional triangle shape. Which length is the height of the prism? That length that makes it transform from a two-dimensional object into a three-dimensional object. Well, hopefully you recognize this is the height of the prism. That little p is just a label. So times the height of the prism, which is 13. Now, if you wanted to, you could cancel this down first. You could do 12 times 6, or you could even be cleverer and do, 2 goes into 2 once and then goes into 12 6 times. So that could be written as 6 times 6 times 13, which would be 36 times 13. Okay, putting that into our calculator, we get 468. Okay, 468. It's time for the next example, yeah? Hopefully you recognized, no, it's not. We need units here. So what units would this have? Well, it's a three-dimensional thing, and luckily all of our units were in meters. If we had had something in different units, you would have, of course, had to have changed that. So that's going to be meters cubed. Very nice. Alrighty, we have another shape here, and this is a cylinder. Now, it says there's a little star here, so let's have a look about what that star's telling us. It says, although a cylinder is not a prism. I wonder why a cylinder is not a prism. Let's look at our definition for prism again. It had to be a straight-sided 3D shape. So this isn't straight-sided, but it is a 3D shape. What do you think the cross-section of a cylinder is? Well, hopefully you recognize it's a circle. I like to draw cylinders like this. I draw the circle, and you might like to draw the circle underneath, and then just join up the two sort of sides of the circle there. We could take a slice here or a slice here. We're going to get the same size and shaped circle the whole way along. So although it's not a prism, we can still use the same formula, which is V equals AH. And the reason for that is because we still have a uniform cross-section. Whew, I'm glad we can. Okay, let's actually do it. So we're going to use this same formula again. We're going to use V equals AH. Now, what is the area of that cross-section? Well, we said the cross-section was a circle. How do we find the area of a circle? Well, the area is going to be pi r squared. That sounds like area to me. So let's change area in our formula to pi r squared, and then we're just going to drop that h down. Awesome. So pi times 3 squared times, what's the height of this cylinder? Very good. It's going to be that 10 centimeters here. Now, sometimes you might see cylinders drawn like this, lying on their side. And sometimes people will actually go in, and they'll make this one like dotted, because it's like we're looking through the cylinder there. If we had a cylinder like that, this would be the height of the cylinder, because it's the thing that transforms it from just a regular old 2D circle into a three-dimensional shape. Now, we want to find this just like the other one to 2 decimal places, and we're going to do that in a moment. The units of that, what would that be? Centimeters cubed. But I notice, because I've read ahead in the question, we also want to find the exact volume of the cylinder. Now, when it says exact volume, that's another way of saying in terms of pi. So when you see exact, well, pi is exact. That's a number that goes on forever. And if we just put it into our calculator like before, we actually have to round that off. So that's not exact. So having pi in there, that's as exact as you can get. How could we write that in exact form or in terms of pi? Well, looking at what we've got here, I notice that we've got pi, but it's times 3 squared times 10. Well, let's do that 3 squared times 10. BidMaths tells us we do the power first, so 3 squared is 9, times 10 is 90. So the exact volume, I'm going to do it in rainbow pen, I'm that excited about it, is going to be 90 pi centimeters cubed. Oh, that was fun. Okay, now let's go ahead and do it to 2 decimal places. So we're going to do pi times, let's check that we got this right. So if we do 3 squared times 10, we should get the same answer as if we did 90 pi. So let's see if we get 282. Oh, thank goodness. So if we did this to, it was 2 decimal places the question wanted, that would be 0.74. So with this question here, we've answered it to 2 decimal places, and we also did it in exact form, which means in terms of pi, 90 pi centimeters cubed. Oh, okay. We've got a bit of a crazy solid going on here, and we want to find the volume of it. There's quite a few ways you can do this question, but in my opinion, I think the simplest way is to just find the area of the cross-section and then multiply it by the height of the prism. So, in this shape here, and some drawing tips here, if you were to draw this with a ruler and a pencil, I would draw this shape. Then, there's a few ways you might like to do this, but some people like to measure the same length for all of these sides I'm drawing now, and the same sort of angle, and then join those together. And then we'll do the little hole and draw that in there. That's just one way. If you're artistic, you're probably much better at this than me. So let's find the area of the cross-section. Now the cross-section here, it's actually this fun little sort of cut-out shape. So that area, let's maybe do this separately because this is a composite area. And that's going to be the area of the big rectangle minus the area of the small rectangle. Hopefully you can see we've got a big rectangle and we've cut this small rectangle out of it. So that area, we're going to have length times width for the big rectangle. Let's be crazy and do capital LW. Normally we would just do lowercase. Or if you wanted to be super clever and you didn't want to do it this way at all, because I know some of you may not have enjoyed my example like that last lesson, you might like to call this big rectangle area 1, and you might like to call this little rectangle area 2. So if you like that, we could do area 1 minus area 2. I don't mind which way you do it, so long as you're very clear about what you're doing. So if we did that, we'd have either you could do big LW or you could do length 1 W1 minus length 2 W2. That would be really nice. So the length and width of shape 1, that was our big rectangle. The length is going to be this 11 meters and the width is going to be this 8 meters. So 11 times 8, we're at our substitution step. Then for area 2, I'm just going to clean this up, we're going to have a length of, that would be 7 centimeters, I see it's written here, and our width would be 4, so 7 times 4. Again, if you've got a negative answer for this, you probably accidentally mixed up your shapes. 7 times 4, so that's 60. And what units would that be in? Centimeters squared. So now when we do volume equals AH the area of this cross section, we're going to pop it in here, and this 32 centimeters, that's going to be our h. So we're going to have 60 times 32. That's 1,920 centimeters cubed. So notice our units. When we did the area of the cross section, it was centimeters squared. But when we did our volume, it was centimeters cubed. This one is a little bit of a challenge. We've got the volume of a prism is 792 centimeters cubed. So they've told us the volume. Interesting. I'm looking at the shape here and some tips to draw this. Ooh, let's get out something that's not a highlighter. Some tips to draw this. I would draw this kind of U shape. And then draw this line here and draw some lines going into the page. And then this one goes down and that one shows that the U's going into the page. It's a fun shape. So observing this shape, I notice we don't have this height, the height of the prism. Ah, they're asking about it later. They've called it the length of the prism, but we know we've been calling that little h. So they're guiding us through how to do this. First off, we want to find the area of the cross section. Now there's a bunch of different ways you could find this area, but the way I think I'd like to do it is I'm going to look at this area of a rectangle and then cut out this rectangle here. I'm going to call the big rectangle area 1 and the small rectangle area 2. Let's have a go at that. Okay, I was going along with this question and I was about to do the area of the smaller shape. This pink side that I've got here, this is the length of that smaller rectangle, 7. But then I was about to have a look at this green one and I noticed, oh, I don't actually have that side length. But I think we can figure it out. I know that this length along here is 8 centimeters. And I know these two lengths are 2, so that means this must be 2 centimeters and this must be 2 centimeters. So what does it mean that this length in between these two has to be? Hopefully you recognize it's going to be 4 centimeters. So let's keep going with that question. Awesome, so our cross-sectional area is 44 centimeters squared. Now we want to be able to find the length of the prism. Now you might be feeling a bit stuck at the moment, but let's do it like we normally would. Let's write volume equals AH, and let's put in what we know. Well, we're told the volume of the prism is 792 centimeters cubed. And did we check everything's in centimeters? Yep, everything's in centimeters. We're told the area is 44, and we don't know what that height is. But I reckon we can solve this like an equation. Let's rewrite it. So it's 44h equals 792. What do you think that we would do to both sides to be able to solve this equation? Well, hopefully you recognise we've got 44 times h, so we'd need to divide both sides. H equals, let's see what 792 divided by 44 is. Ah, so that height is going to be 18, and our units, centimetres. Oh, that was a bit fun. Okay, good luck with your questions, and I'll see you later.